All right, 4-5 in Advanced Algebra 2. We're solving some linear inequalities by graphing today. This is a huge setup for linear programming, which is what we'll do next class period. So it should be a pretty basic day, but it's very important to learn to make the linear programming go a lot faster. So we've done this a long, long time ago back in algebra. Remember just graphing lines, but there's not equal signs. There's inequality signs like less thans or greater thans and all that good stuff. That's where you have to like graph the line, decide if it's solid or dashed, and do some shading to figure out where the solutions are at. So first two problems are just total warm-ups to refresh our memory. So number one, hey, is y all by itself in this first equation right here? That's nice. So he's in slope-intercept form. What's the y-intercept? 2. Start at 2. And the slope is 1/3. You know, like the x is up in the numerator. That's kind of a weird spot. You don't see him up there very, but it's like 1/3 with an x with it. So we'd rise 1, run 3. Rise 1, run 3. I like 4 points on the line if you can put them. Sometimes you can't. Remember, then you got to decide if you want a solid line or a dashed line. Because this does not have an equal to bar underneath, what do you think? Solid line or dashed line? Dashed line. So we'll make that dashed line. And now, let's not waste a lot of pencil today because we have to do some shading. And there's some tricks. There's a lot of rules of where you're supposed to shade, but here's the trick. If y is by itself, you can do this simple trick. All you got to do is know what that symbol is. Isn't that a less than symbol? So that means that you would shade below that line. But let's not waste a lot of space because we're going to have another line. Sometimes we might have 3 lines. Sometimes we might have 5 lines that we're going to graph on the same thing. And it can get messy with all this shading. So what I do is just put this little helper shade. Say, hey, just helping my eyes. It's like I'm supposed to shade below that line. So I'm not wasting a lot of pencil, but just a little bit of shade below says, okay, with this red line right here, I got to shade below. And then on this guy, he's also in slope-intercept form, so that is nice. Y-intercept of 1, meow, 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 meow. Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. The biggest mistake we'll probably make is the type of line, solid or dashed. You know, we're so used to putting a solid line all the time. Why does this got to be a dashed line? No equal to bar, right? So making that dashed line. And then using this symbol, because y is by itself, we can let the symbol just tell us where to shade. Aren't we supposed to shade below this blue line because that's a less than symbol, right? So to shade below the blue line, remember we also want to shade below this red line, like we're going to, like where the shades overlap is where our answer is. So would you believe it's just basically this region down here? Isn't this below the blue line and at the same time below the red line? So you can shade that in real nice with your pencil. You don't need to waste a lot of pencil, but just let me know that this whole area is where all of the solutions to this system are. Just to kind of do my job here, any ordered pair in this green shaded region is going to make the top line true and the bottom line true. It's like it satisfies both of those inequalities. So that's old school. Remember that? You know, it's been a while, but remember doing stuff like that? Let's do another one of those. Just a warmer upper. So y is all by itself. That's nice. Y is greater than or equal to x plus 5. Doesn't he have a y-intercept of the 5 and a slope of 1? Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. What kind of line? Solid or dashed? Solid, because this is an equal to bar, meaning any point on that line also works. It satisfies this guy. So that's nice. To shade, since y is by itself, you can read the symbol. And this says y is greater than. So a greater than, doesn't that more mean above the line instead? So we'll just do a little helper shade. We're supposed to be going above this guy. Now let's graph the other line. I'll let you do that. Pause the video. So I got them graphed, right? It's this blue dashed line. But could you tell me just the lines themselves has nothing to do with the shading. What do you know about these two lines right here? They are parallel. Don't they have the same slope? So where should we shade in this blue line? Since that's a less than, shade above it or shade below it? Below it. And would you believe we are looking where the shades are supposed to overlap? What do you think? Where will the shades overlap? They're not going to, so our answer to this system is going to be what, since there was no place where the shades overlap? No solutions. But what you need to understand is that doesn't always happen just because you have parallel lines when you're graphing inequalities. You still have to do the shading. Because what could happen is I could switch these symbols around, you know, and make this a less than and this a greater than, and I could shade below this line and above this line, and wouldn't the shades like totally overlap in that case? So just because the lines are parallel does not mean there is no solutions to this. It's because the shades never overlapped. That's why there was no solutions to this. So you cool with that? Those were warm-ups, just refreshing the memory. Now these, if you notice, yes, we're going to do more lines, but they asked for the vertices, and I don't know if you've ever done that before. So we're just going to take it one at a time, and for those who are color coordinated, you might like to highlight these. So we'll need like 3 different colors today if you want them. So we might want to highlight, we might not, but instead of highlighting, some people number their lines, so I'll show you what I mean by that. First things first, holy cow, we go old school. See this first dude right here? It's only got X's in it. Do you remember what kind of line that's going to be? A horizontal line, which only has Y's in it, a vertical line, or an oblique line? What do you think? It's got to be vertical because it's only got X's. This dude's going to be oblique because he's got X's and Y's. This dude's going to be oblique, so we're going to go draw ourselves a vertical line. It's going to go through -3 on the x-axis, and could you tell me, is it a solid vertical line or is it a dashed vertical line? Dashed. So, boom. What some students do instead of highlighting is they just call this line 1 and they put a number 1 by it. That kind of helps them when we have to find these vertices later. So this was like line 1 in this case. It will get a little more complicated as we go. Then if we do line 2, he is going to be oblique because it's got Y's and X's in it. And it's nice that Y, oh sorry, I forgot to do some shading. Let's do a little helper shade. Would you believe this is a greater than symbol, right? So you can't go above or below a vertical line, so it's either to the right or to the left. Where do you think greater than means, to the right or to the left? Yeah, a little bit of helper shade over here. Helps your eyes out, especially when we start getting 4 lines, 5 lines, you know, it's like, holy cow. So we got this guy shaded to the right. Let's go ahead and graph the next dude, which is oblique. He's got a y-intercept of 3. Unless he's blue, dude. 3. And down 1 to the right 3. Down 1 to the right 3. I could also go up 1 and to the left 3 if I really wanted to. Ooh, that was kind of nice. Did you notice what I just kind of did right here? I went up 1 and to the left 3, and did I get a blue dot on top of that red line? That's kind of what the vertices are about, is like where these lines intersect each other at. That's not really the truth, but we'll clean that up in a little bit. But it's nice to know if that happens at a nice, neat grid point. And well, that's a dashed line, right? So, meow. And you might want to call him line 2 and put a number 2 by him. Or if you're highlighting, that's a second color altogether. Like notice I have a red line and I have a blue line. It's up to you. The only bad thing about highlighting is you can't erase it if you make a mistake. So we just got to fix it. And then we'll do the third line. I'll let you do that. He's oblique because he's got Y's and X's with it. And he's in slope-intercept form. So, rise 1, run 1, rise 1, run 1, rise 1, run 1. Nice. Got a green dot on top of a blue dot. So that's pretty nice to find those vertices. Dashed line as well. And call him like line 3. And you have definitely graphed these type of systems of inequalities before where you had 3 lines. And we got to do the final shade. Sorry if I'm moving too fast. The final shade, remember, this is where the helper shade shows up. We got to go like totally to the right of the red line, below the blue line, and at the same time, would you believe we're going above the green line in that case? So wouldn't all 3 of those, the shade, like totally be in this region in here? So you can shade that in. This is a solution to all 3 of these systems, and this will be something that's really important when we get to linear programming. When we get a story involved with it, which is some of the most realistic things we'll ever do in this class, this shaded region means something. And what means something even more is these vertices. The vertices are, would you believe, like when I shaded that in, I got a polygon, like, you know, like a triangle back, you know, like it made a polygonal region in that case. So the corners of that are the vertices. So let's do this. Let's label them. I usually put letters on them like A, B, C, D, whatever, however many it is. There should be 3 on this one. So put big old fatty boom batty dots on them. Let's put a B there. And label them A, B, C. Because they are asking us where these vertices are. It really doesn't matter which one's A, B, and C. It's just so I know which ones you're looking at. Could you tell me where A is located on the graph? Negative 3, 4. So we'll go down to the vertices. We'll put an A next to it and do negative 3, 4. Then we'll go with B. Isn't B 3, 2? Is that right? And then we'll do C. I'll let you figure out where C is. Boy, wasn't that stinking pretty easy to find those vertices. Because they landed on grid marks. That was really, really, really easy to find those vertices on this problem. But let me also show it to you this way. Would you believe that this vertex B was where the green line and the blue line intersected each other at, and this is where the red line and the blue line intersected each other at, and this is where the green line and the red line intersected each other at, and that was just so stinking nice that they landed on the grid lines. But they don't always do that. So let's go for the last kind of warm-up, but it is a long one and a challenging one. But I've got some shortcuts for you. And we need to learn this shortcut. If you're like saying, I don't want to do it that way, trust me, for what we got to do on the backside, you're going to have to learn to do it this way. There's like no other way to do these tough ones. So check it out. Would you believe that this line right here is oblique because he's got x's and y's with it, right? But it doesn't have y all by itself. And that's okay. This is called standard form of a line. AX plus BY equals C, even though it's not an equal sign. And you have learned very, very little about standard form of a line. Well, today is the day where standard form of a line is going to pay off in spades. What we will do to graph it in standard form of a line, instead of getting y by itself, which is going to be a disaster for us on the next page, right? We don't want to get y by itself. We are going to make, let's call this line 1 right here, and we are going to make a little bitty baby table of values, because the fast way to graph things in standard form is to find the x and y intercepts. And here's how you find the x and y intercepts. Like, you make a little table, here's x's, here's y's. To find the x-intercept, you're going to let y equal 0. So I'm going to go ahead and put a 0 in that spot already. And then I'm going to go down to a different line because I'm going to have a different set. There's only going to be 2 things in our table. To find the y-intercept, you let x equal 0. And I know you have done this before. It has just only been maybe like for one day of your math life where you have ever done this before, but it might bring back some memories. Here's how you can very easily, with a calculator of course, still compute the x and y intercepts. I'm going to let y equal 0 in this line. So if I went up here and literally substituted 0 in for y right here, could you tell me what 4 times 0 turns out to be? 0. So basically this disappears. Please don't scratch it out, you know, but this disappears, right? And just pretend these are equal signs instead of like inequality signs for a second. Would you believe that this now says 5x equals 20 in that case? Could you totally just solve this for x? Like if I wrote this equation right here off to the side for you, could you solve that for x? What does x have to equal? 4. Boom. There you go. That is the x-intercept. To find the x-intercept, you let y equal 0. And we call it the cover-up method because you could just like take your finger or take a thumb and just cover that up because that's going to disappear because we let y equal 0. Well, it's the same concept to find the y-intercept, don't you? Let x equal 0. If I let x equal 0, isn't 5 times 0 turn out to be nothing? So that goes away. Never cover up this sign, though, because that could be negative, and that might make things different. But then you just divide. What's 20 divided by 4 turn out to be? Do you remember doing that? before. It's been a long time since you've done it. But now, all we do to graph this line is go plot those points. Let's go plot 4, 0. Is that the red dot, or is that the green dot right here? Which one's 4, 0? Red dot or green dot? Got to go to 4 on the x-axis, 0 on the y-axis, so it's the red dot. And then we plot 0, 5, which is right here. And all you do is connect them together. Hey, hold on. How should we connect them together? With a solid line or with a dashed line? Dash. Sound cool with that? Making a little baby table. Let's go throw a number 1 by that line right away. This is where, if you already know you're a highlighter person, please highlight that a color. Highlight this line the same color that you did it. And maybe even highlight this table that same color. That's if you know you're a highlighter person. So cool with that. Yes. That's what we're going to do. That's where I was going. Thank you for reminding me. We do have to shade it also. And the shading, now my trick is gone. That trick about above and below only works if y is all by itself. Y is not all by itself. So we have to do the real method, which is called use a test point. And to make a long story short, you just pick a point that's not on the line. Like you could pick this point that's not on the line, and you go substitute them in and see if you get a true or false statement. You could pick any point you wanted to. Let me tell you the point you should use every single time. 0, 0. Isn't 0 like the easiest number to deal with in mathematics? So if we pick 0, 0, that means I need to put 0 in for x, and I need to put 0 in for y, because I'm substituting in to see if this statement is true or false, right? So if I put 0 in for x, 5 times 0 is nothing, right? If I put 0 in for y, 4 times 0 is nothing. Would you believe you would get a 0 left on this side? And it's asking you if 0 is less than 20. You with me on that? True or false? Is 0 less than 20? That is true. So since it was true, you go look and see where this point was. Is this point above or below? That means you would shade below that line because it was a true thing. Wherever this point is on a true statement, you shade below. That is weird. We will do many more of them if you were not sure about that. But true means since that point was below, you will shade it below. Just helper shade though. So, okay with that? Line 2, oblique, is y by itself. Please graph that line. Y is already all by itself. But that whole shading thing is a little weird on those standard form lines. So if you use a dashed line, throw a number 2 by him. That's going to help every single person. If you're a highlighter person, pick a second colored highlighter. I highlighted him blue, so I would go highlight this line blue right here. That's not blue, but I would do this blue. And now we can do the shading trick from before because y is all by itself. So this is a less than. Doesn't that mean we're going below? So just a little bit of helper shade. And there is no reason for me to put helper shade over here, right? Like putting helper shade in this region is pointless because doesn't it also have to be on the other side of this red line? So it's like there's no need to put it over there. I'm just putting her down here. Cool? So that's line 2. Line 3 is totally in standard form again, right? You got x, y equals number in that case. So that's where we're going to learn to put a little 3 here, make a little table of values. Put some zeros in there. Doesn't matter where the zeros go. I do it the same way every time if I can get my pen to work right. I throw a 0 for the y first. I throw a 0 in the x second. That's just how I roll. And I'm going to let y equal 0 in this very first deal. If you let y equal 0, would you believe this nugget goes away? And you've got x equals 4. It's just pretty much what that says. Remember, you're just treating that as an equal sign. So 4 is the x-intercept of that guy. You feel all right with that? Then you go reverse, reverse, and you have to let x equal 0. So this goes away because there's nothing there. And you got negative 3y equals 4. Wouldn't you have to divide by negative 3? And that's not going to come out right, so we're just going to leave it negative 4/3. Notice the negative, though, like you don't want to cover that up. Let's go plotting those points. First point, 4, 0. Boom! Oh, that's beautiful. Got a green dot on top of a red dot. That's nice. Negative 4/3 we're just going to have to guess. Do you know what that is like as a decimal? If you're not sure, you could always punch it in. Do -4 divided by 3. And it's like -1.3 repeating in that case, you know. So isn't that a little lower than -1, but still above -2? So we're going to put him like right about there. So that was pretty close to where -4/3 was. Okay with that? Connect the dots. What kind of line should you make? Solid or dashed? Dashed. And here's where that test point comes in again. We got to do the test point. Always, always, always test 0, 0. I'm going to test, you don't have to draw the point 0, 0, but you test 0, 0 because this will come out to be 0 every time, and this will come out to be 0 every time. It's like all this goes away, and you just got to ask yourself, true or false, bro? Is 0 less than 4? True or false? That is true. So, since that is true, where was that blue, where was 0, 0 in relation to that green line? Above him or below him? Above him. That means you will shade above him. And following all the other shade, you got to be below this blue line, above the green line, and below this red line. So this nice triangular region is where we're at. And here again, we've got this called line 3. If we haven't done that yet, you got the 3 lines, because we're going to need that to figure out where the vertices are at. The vertices is the real important thing. That is the most important thing of the linear programming, is where the heck are these vertices at? I can tell you, how do you feel about this one right here? Do you know where this vertex is at? 4, 0. So let's label these first. Let's just go ahead and call him A right away. And A is at 4, 0. That happened at a nice, neat place. Correct? But check this dude out. It's close, but I can't be for sure. So that sucks. Let's put a B there. It doesn't look like it's on a grid mark. So I need to know which 2 lines intersect there. That's why numbering them helps, or coloring them helps. Would you believe that this is the green line and the blue line, which for me is line 2, meow, 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 and line 3 in this case. I need to know where they intersect. And dear friends, if you haven't figured it out yet, that is the entire point of solving a system of equations, is figuring out where those lines intersect, right? So we will solve a system. And because we have something that does it very nice for us called a matrix, I would like to use a matrix to solve a system. The system is only between these 2 lines, though. The red line has nothing to do with this point right here. So here's the other question I have for you. Uh-oh. You have to be in the right order to do a matrix. It has to go x, y equals number. Doesn't the green line go in that order? X, y equals number. But the blue line doesn't. Doesn't it have to go x, y equals number? This dude right here needs to move over. So I'm going to move him over. Isn't that negative 2x plus 1y is less than 3, or you could use it equals 3, whatever. But I got to put this in a matrix, and I got to put this in a matrix. So let's go do it. Okay, I'm into my matrix. So I got a negative 2, enter, a 1, enter, and a 3, enter. And then I got to go see the other guy. Isn't it a 1, enter? It's a minus 3, right? Uh-oh. 1, enter. Come on. Minus 3, enter. And 4, enter. Quit out of it. Then go do reduced row echelon form on it. Matrix A. Boom. And it came out decimally, right? That's totally fine. I'm good with the decimals on a graph, you know, no problem. Nice clean decimals is what this is. And that's probably supposed to be expected. It didn't come out on a nice, neat place, you know what I mean? So it had to be in a weird spot. Thank you, Matrix, for showing us where that is. And again, next week we will learn what's so stinking important about this point. So it was negative 2.6, negative 2.2. Is that what you guys got also? Okay. So that was to find point B. We still got point C up here to find. Which two lines intersect at point C? Blue and red, or 1 and 2, however you want to say it, right? You know, like having them numbered in that case. So I now got to go do a matrix with those two guys. Wherever the two lines are that intersect, those are the two guys you got to put in the matrix in that case. So top one's in the order you want them, x, y equals number. Middle one, we just put them in there, so we got this guy. So we got to go back and edit our matrix. Second matrix, edit the 2 by 3. And you can put him in there. This one was already there, so I don't need to retype him, but the top one went 5, 4, 20. Is that right? Yeah, 5, 4, 20. It doesn't matter which one's on top and which one's on bottom in the matrix. One of them had to go negative 2, 1, 3. The other one had to go 5, 4, 20, so they both do. Quit out of it and do reduced row echelon form, which is my previous entry. And yo, look at that ugly crap. It's supposed to happen at an ugly place. Let's see if that turns into fractions real nice, though, since those decimals are really nasty. How do you change them into fractions? Math enter that dude. That'll work, right? So, happened at nasty places. This was by far a much more challenging problem. So, C was at 8/13, comma 55/13. Weird. What does it mean? We'll find out next week. But those vertices are very, 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 very important to some real-life scenarios. So that was crazy. Let's practice some more. So did all that on that big slide. Now, here's some of these real-life like inequalities that you'll see in the linear programming. There's a story that goes along with it. We don't need the story today. It's just like, here's some real-life inequalities. They're huge. Look at the graph that I've given you. It doesn't even have a scale on it. It doesn't have any of that stuff. We have to figure all that out ourselves. So before we can do any graphing, we need to kind of know what the heck the scale is supposed to be. So first, check it out. 4 guys, right? This dude is nothing to us. We don't care about him until later, because isn't this just a vertical line that goes on 0, right? Isn't this just a stupid horizontal line right here that'll go on 0? These are the 2 guys we care about. So let's call him line 1. And what we are going to do, because he is in standard form, is go find his x and y intercepts. Line 1. So we'll make a little baby table. Feel free to grab a calculator, of course. Throw in a couple of zeros. This is required work also on linear programming. You get points for making little baby tables and stuff like that. So let's let y equal 0. And that basically means we got to do this. Don't we got to take 3,450 and divide it by 30, right, to figure that out. So I'll let you punch that in real quick, and you tell me if you get 115 back. Did you get 115 back for that? Yes? So that's nice. Would you believe there's no way that 115 for an x-intercept is going to fit on a graph like this? You know, it's like, it's just, this is not a very realistic graph scenario, so we're going to have to make our own graph. Then we got to go do the y-intercept, so we'll put 0 in for x, and that goes away, and then we take 3,450 and divide it by 50, right? What did you get back? We all okay with that? Nice. That's for this line. We can't go graphing it yet because we got to know what happens on the other line. It's like, how do I know what that biggest x value is going to be? We've got to get all of the tables made first before we can roll with it. So that was for line 1. Let's do the same thing for line 2. Make some baby tables, and let's find the x and y intercepts. Then we'll be able to make a graph. So some zeros, meowie and meowie. If we let y equal 0, I got to take 23,500 and divide it by the 250. And I know we can punch that in a calculator, so I'm just not going to waste time to do it. Henry, what'd you get? 94. Is that okay with you guys? 94 for that guy? Nice. Then let's go find the x-intercept, excuse me, the y-intercept, because that's where you let x equal 0. So 23,500 divided by 300. 23,500 divided by 300. Ooh. 0.3 repeating. Do you know what 0.3 repeating is as a fraction? 1/3. So since that's nice, we'll call it 78 and 1/3. If it was really weird, we would round it to the nearest tenth. Sometimes that's going to happen where it doesn't come out so nice. So we'll call that 78 and 1/3. Are you good with that? So first question. So finding these numbers is phase 1. Phase 2 is figuring out what the x-axis needs to go by and what the y-axis needs to go by. We're always going to be in the positive coordinate also. Like if we had a regular old graph, we're always going to be in this quadrant right here. It's like we're not going to have any negative x values, any negative y values, nothing like that, because these are real life story problems where nothing goes negative. So what we got to do is we got to figure out what to go by on the x-axis. And let me grab a highlighter. Would you believe these are x numbers in either column, right? Aren't those the x numbers? Who's the biggest number you see out of all the x's? 115 is the biggest x value we got to get to, right? We've got to get our graph to go up to 115. Well, let's count how many spaces available there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces available. You good with where I got that from? Let's grab our calculator, and here's all you got to do. You got to take the number that you get up to, which you said that was 115, and we're going to split it up 13 ways, because isn't there 13 spaces available? So we'll split it up 13 ways, and you'll get a nasty number like this. What we need to do is round that up to the nearest easy number to count by. You know, like that definitely rounds up to 9, right? Do you like counting by 9s? No. What's the first number that's bigger than 8 that you really like to count by? 10s. So that means we want our scale here to count by 10s. So let's start with 0. And you know what? Watch this cool little trick. I'm not even going to put every single one. I'm going to skip a space. This would be 10. Wouldn't this guy be 20? This one's 30. This one's 40. You see how I'm counting by 10s, but I'm only listing every other one of these, just to kind of save my hand from writing so much stuff. Would you believe that I 100% counted by 10s on that bottom scale, even though I only listed every other one? I took the x numbers, found the biggest one we had, and split them up 13 ways, because that was the spaces available, and rounded up to a nice easy number to count by. Redo the whole process for y's. What is the biggest y number? 78, basically, right? Figure out how many spaces you got. It's not 13. Figure out how many spaces you got. How many? 10. So you can just basically round that 78 off. You know, you're going to have to round things anyway. So 78 split up 10 ways would be 7.8. Round that up to the next nearest number to count by. What would be the easiest number to count by bigger than 7.8? 10s again. On these, I'm actually going to list every single one. So just because there's not that many of them. So count by 10s. Go all the way up. Don't just stop at 80 because it's like, oh, we don't have to go any higher than that. Go all the way up. Finish the. So that was neat, figuring out what to count by. Biggest y number divided by spaces available. Okay. Now, here's what we got to do. We got to go graph these two guys. Isn't x greater than or equal to 0, this vertical dude right here? And isn't y greater than or equal to 0, this horizontal guy in this guy? So use your straight edge, please. Graph those guys. It's basically just the x-axis and the y-axis is what that's making us graph. I put an arrow on them, too, just for fun. But x is a vertical line. X equals 0 is a vertical line that goes through 0. Nice and neat, straight up. Y equals 0 is a horizontal line going through 0. And would you believe, you don't even need to put the baby shade on these because it's going to make things messy. But it says these have to be greater than 0, so I'll show you the baby shade. Isn't this where it would be shaded on the right side? And isn't this guy going to be shaded above this dude right here? In that case, you don't need the baby shade. Once you get used to these, it's like, yep, we're going to shade in that quadrant is kind of what it's saying. So don't need that. But now we got all the work done. I just need to get rid of this because I want to get this mess out of the way. We got all the work done to go graphing the lines. We're not even going to make true lines. We're going to make segments. Let's do this green one. Doesn't he have an x-intercept of 115, 0? So we've got to go roughly put that. Here's 100 Here's 110. Isn't 115 pretty much right about here? Because you are in no man's land, you are not actually on a grid mark, you must write that ordered pair, 115, comma 0. So that way we know exactly where it's at, 115, comma 0. Then, isn't the y-intercept 069, which is pretty darn close to 70, but not quite on it. Because you're in no man's land, you must put 069 for an ordered pair. You with me on that? Connect the two dots together with what kind of line? We'll look at line 1, and isn't that a solid line in that case? But I don't even need the true line. We're going to make it just a segment. Just connect those two dots together, because it's not going to go down here. It's not going to go up here. Like, it's off the graph in that case. So we don't need arrows. And just put her like that. And now we'll go put some baby shade, though, to figure out where this guy needs to be shaded. How do you figure that out? Since it's in standard form, use a test point. Hey, what point should we use every time as our test point? 0, 0. Doesn't that just wipe this entire thing out right here? So the whole side becomes 0. 0 less than 3450. True or false? Is 0 less than 3450? Yes. Here is 0, 0 as an ordered pair. He is below that line, right? And that was a true statement, so that means our baby shade is going to go below that line. So because the test point was true and it was below the line, that means you would totally shade below the line. If the test point was false and the point was below, you'd shade above it. You'd go in the opposite direction. Then graph the blue line. We're going to plot his ordered pairs, so 94, 0. So that's like right here, my friends. And 0, 78 and a third. 0, 78 and a third. Connect together. Because there's an equal to bar, we need a solid line. So, and then we'll go figuring out where to shade by testing a point. We're going to test 0, 0 again, so this all gets wiped out, and it's 0 less than 23,500. True or false? That's true. Isn't the test point below the blue line in that case? So that means we're supposed to shade below the blue line, so a little bit of helper shade if you need it. But would you believe now we can finally start shading the final region? We're out of lines. We got to be below the green line, below the blue line, and don't forget about the two guys that we had already, these original red dudes. So we got to be above this, to the right of this, below the green line, and below the blue line. And isn't this the region that needs to get shaded in that case? If I move too fast on the video, you can always pause it. But it had to go below the green line, below the blue line, and above the x and y axis, or to the right of it, you know. It's got to stay in that region. Now, would you believe this is not a triangle anymore? This is like a quadrilateral. Doesn't it have 4 sides? So to find the vertices, they're all the corner points. I'm going to go black. I usually go down here and call him A right away. I'm going to call this B right here. I'm going to call this C right there. And I'm going to call this D right there. I usually just start at the origin and go around the clock clockwise. So A, B, C, D. And any nice, neat places, we're going to use those nice, neat places. Vertice A, that's pretty obvious. 0, 0. Anybody know where B is located? 0, I think, is it the 78 and 1/3 or is it the 69? Yeah, it's hard. It depends on where you wrote that stuff down at. Isn't that at 069? Is that right? So 069. How about C? We're going to come back to C. Do you know where D is located at? Yeah. There's just one of those points we're going to have to go hunting for. Because it didn't happen at a nice, neat grid line. C is where the green line and the blue line intersect each other at. And isn't that these two home slices right here in this case? So why don't we use a matrix to figure out where they intersect each other at? So we'll go 30, boom, 50, boom, 3, 4, 5, 0, boom, 250, 300, and 23,500. Enter. Quit out of it. Do reduced row echelon form on him. Boom. Did happen at a nice, neat place, but mine didn't quite work out that way. That's all right that it didn't. Did yours land on 40, 50, nice and neat? That's fine. If you can see that, it's just all in human error of like totally like, oops, I missed it just a little bit, so it happened at 40, 50.
I thought it said 40, 45.
That's what I meant. Thank you. 40, 45. Okay, I thought it said, yeah, that's why it didn't land at, because I was thinking it said 40, 50. So yeah, 40, 45 makes a lot more sense of why it didn't land on a grid line in that case. So did you get 40, 45 back? Thank you. I misread it when I saw it on the calculator. I thought it said 40, 50. So thank you, thank you, thank you. 40, 45. That's why it didn't land right here on 40, 40, where I thought it was. So anyway, these vertices, find out next time what those are all about, right? But they are the most important thing. Just one more problem. Cool? It's a little bit different, yet exactly the same. First things first, I made a typo, and the easiest way to fix it, see this third line, or excuse me, the fourth line right here, cross the whole stinking thing out right there. Just cross it out. Instead of graphing these 5 lines, we're only going to graph the 4 lines, right? So we got the top 2, then the one with the 12, 18, 198, and then the 6, 375. Those are the only ones we're going to graph. Cool? So sorry for the typo. Okay, how do we start? Baby tables. Please pause the video, make a little baby table for line 1 here, and then make a little baby table for line 2, and then join me again. Page. Hopefully, you got your table to be this. You got a 16.5 and an 11 in table 1, and a 12.5 and a 25. What is this important for? Finding the scale of what to count by. We got to go to the x scale. I usually go with the x scale first. What is the biggest number that I got right here? 16.5. So I have to get up to 16.5 on the x scale. Again, there's still 13 spaces available, right? 13 spaces available. So in a general rule, if you need help figuring that out, you take what you got to get up to, 16.5, and divide it by 13. I think you know you can't make it counting by ones, but if you rounded this nasty number up to the next easiest number to count by, what would you round to? 5's too much, right? I like 2. We also want to try to make it as small as possible, so counting by 2's is pretty easy for most people, you know what I mean? So let's count by 2's. So I actually went and listed every single one of them, because 10s is something that's really easy to see who's between. 2's, for some people, they have a hard time when you go every other one seeing, like, where's the 6 at? You know, where's this at? So I just went ahead and listed every one. 25. There's 10 spaces available. Ooh, watch this. Watch this. 25 divided by 10. Ooh. 2.5s. People are like, let's count by 3's. There's nothing wrong with counting by 3's. I wouldn't mark you wrong if you counted by 3's. But I think you can count by 2.5's really easy if you just watch this. Hey, if this is 2.5, do you know how much this one is? So like every other one is going to be a multiple of 5. This is 5, skip a space, 10, skip a space, 15, skip a space, 20, skip a space, 25, because you really did count by 2.5s. So we just needed to get up to 25. We did. It's just kind of weird that we counted by 2.5s, but that works really, really nice if you go every other one. But please realize if you counted by 3's, I ain't marking you wrong. If you counted by 4's, I ain't marking you wrong. If you counted by 5's, you're just squeezing the graph too small. You want to try to spread it out. So that's nice. Let's plot the blue line. Excuse me, I meant the green line's information, 16.5. So remember, halfway is 17. You want to get kind of right about here. So 16.5 16.5. Don't forget to draw your x and y axis. I kind of already had that graphed. So 16.50. And 0, 11. So here's 10. Remember, you're counting by 2.5, so this tick mark right here is 12.5. Isn't 11 probably pretty darn close to like right here? That's the bad part about counting by 2.5 is getting into the no man's land is kind of weird. To shade, let's go test a point. Which point do you want to test? 0, 0. So I'll do this, 0 greater than or equal to 198. True or false? That is false now. Here is the point we tested, 0, 0. It is below the line, right? And we got false back. So where do you think that means we're supposed to shade? Above the line. Since false was our answer, we go on the opposite side of the line that 0, 0 is on the side of. So a little helper shade there. You can go do the blue line now. So if we test 0, 0 again, it's basically the same story. 0's over here. You got a greater than or equal to 75, and that's false. That's not true. 0 is not greater than 75. So since 0 is below, 0, 0 is below the blue line, we need to go on the other side of it, and isn't that above? So we got to be above the blue line, above the green line, and don't forget we've got the x and y axis as our boundaries. In this case, they're my purple lines in this case. So to shade, what I usually do, especially if you are using highlighters, remember you can't erase highlighters though, but you got to be above this purple guy, above this green guy, above this blue guy, and then to the right of this. So doesn't all of this area get shaded in that case? Because it's got to be to the greater than this dude, above the blue line, above the green line, and above the purple line. So the biggest mistake students do is always assume this pink region is the guy that gets shaded in. That is not the region that got shaded in this case. It's the orange region that gets shaded in. The symbols were greater than this time, and we did the test point. Vertices. Not always going to be 4 of them, even though you get like a quadrilateral down here. The vertices are the cornery type points of the shaded orange region. So here's one, because it's where these lines intersect each other at A. There's another one right here, dude, at B. And there's another one right here at C. It's where like the corner type places happen of the orange region. There's only 3 of them. A is a nice easy place. I'm going to do A wrong. Tell me what I did wrong about point A. What's wrong about point A? It's 0.25, not 25.0, so just watch out for that. So 0.25. B is where the lines intersect, so we'll need to solve a system with those guys, because it didn't happen at a nice, neat place. If it did happen at a nice, neat place, then you don't need to solve the system, you know, but we're going to need to solve the system, and C was at 16.50. So I will let you use the matrix to solve the system with those 2 guys. It should happen very near where these intersect. If you look at 10.54, that looks pretty darn good right there of where those lines intersected at. So otherwise you either type something in wrong or you just totally graph things wrong. Cool. So not a bad day. This will make what we do next class period a billion times easier. So thank you.